let's talk about the acids of the base. Start with the acids, the first about the occurrence. But acids basically so just give an example. Lemon juice, grapefruit tea, which in the spirit of fermented milk. How so just because of the presence of acids there. So various kinds of acids that are present in this stuff. The acids present in the animal and the plant materials are known as the organic acids. So when you need to the term organic acids, what are they? So these are the acids present in the animal and the plant materials. Now acids such as the hydrochloric acid, sulfuric acid, and the nitric acids are mineral acids. Because they are very from the natural occurring compounds, only the minerals. Also, so if you make to the term mineral acids, what are they? So these are the acids that are naturally occurring acids. They are due to the minerals. Example of them are like such hydrochloric acid, sulfuric acid, and the nitric acid. Now, a substance that is neutralized and acid or neutralized effective on it litmus. So, a substance can be notified maybe or can be known as acid or not by the effective of it on the litmus. So, a litmus is the part of that it can be used as a solution or on a paper only as a litmus paper. Now, a litmus solution is purple in color, and the litmus paper for the testing acids is blue, while that for testing bases is red in color. So you notice if you are trying to measure or to test the acidity, you're going to use the blue litmus paper, and for testing the base, you're going to use the red litmus. Now, the acids will return the litmus solution red. And if it's the blue litmus paper, it will be turned to the red litmus. Now, let's talk more about the bases. Bases not usually occur naturally, so they are not naturally occurring. Basically, they are prepared in the laboratories or industries. The bases can be classified such as the oxide C, hydroxide C, or carbonates. So these are examples of these classifications of bases. And therefore, bases can be defined as the oxide C, hydroxide, and the carbonates of metals. So if you ask me to define the definition or what's the meaning of a base, so a base is defined as oxide, hydroxide, and the carbonates of metals. Now, the bases test beta compared to the acids, which acids are salts. That the bases are beta test. Now, the beta test is the characteristic of all the bases. Now, all the bases are dissolved in water. This means that they do not dissolve in water. The bases which dissolve in water are called alkalis. So the bases that dissolve in water, if they are specific name that is alkalis. Now the most common alkalis are like the potassium hydroxide, sodium hydroxide, potassium hydroxide, and the ammonium hydroxide, also known as ammonia solution. So if you ask me what are the examples of alkalis, so example of alkalis are such as hydrogen, KOH, NOH, CaOH2, and NH4OH. So the OH of sodium, potassium, calcium, and ammonia. Now alkalis turn litmus solution blue and the red litmus paper blue. So a substance such as litmus, which changes from one color to another, when mixed with an acid base, or base, acid or base. We call that indicator. There are various indicators that are used in the chemistry laboratories, such as your people, methyl orange, but there's some of the indicators that are used. Now let's move on to the reactions of acids with the various metals, various materials. Notice that the acids can react with the various materials or various compounds, form various compounds also. So the following are some reactions of the dilute acids with various substances. The first one is the reaction of metals. When acids will react with acids when we react with the quite reactive metals, this means those not very reactive ones produce salt in the reactive hydrogen gas. So that's the formula as these are not mostly reactive metals. When they react with acid, they tend to liberate salt and the hydrogen gas. Now, it is unsafe to try these reactions with the very reactive metals such as sodium and the calcium. As I said before, that the reaction is on those moderate reactive metals. Now, the reaction with the such metals is so violent. So, if you try with these more very reactive metals like sodium and calcium, you might notice that it is very violent. It can be very destructive. Now, the metals less reactive than lead, such as silver and gold, have no reaction with the dilute acids. So that's the one of the points to be taken. Now, the salt produced when a dilute acid reacts with a metal depends on the acid and the metal used. So you can observe it by the various of the reactants before to know what kind of salt is produced. Example, when you magnesium reacts with the nitric acid, you get magnesium nitrate plus hydrogen gas. So that's the magnesium nitrate is one of the salt. Then when you try magnesium plus hydrochloric acid, you get zinc chloride plus hydrogen gas. So that zinc chloride is one of the products, and the hydrogen gas is liberated during the process. Now, let's talk more of the reaction with the various materials, that the reaction with the carbonates. These acids, when they react with the carbonates, they give salt, water, and the carbon dioxide. So in general, all carbonates give off carbon dioxide when they react with the acids. So that's the general concept. If you observe that all carbonates, they give off carbon dioxide when they react with the acids. So acid plus metal carbonate equals to salt, water, and the carbon dioxide. Now, the normal methods of preparing carbon dioxide in the laboratory are based on these reactions. Now, the diluted hydrochloric acid is reacted with marble chips, that is the calcium carbonates. So, if we react to get calcium chloride plus water plus carbon dioxide. Let's move on to the reaction of these acids with the oxides and the hydroxides, which are reacting with the alkalis. These which are the alkalis. Now the hydroxides. Now acids react with the alkalis forming salt and water. That's common law. Example of that one is sodium hydroxide plus nitric acid getting sodium chloride plus water. And the oxides, when they react with these acids, they also form salt and water. Example, zinc oxide plus hydrochloric acid, you get zinc chloride plus water. Now, the bases, these oxides and hydroxides all react the same way with acids, and the process salts are forming. Now, this reaction is known as neutralization reaction. So if you've ever met with this term neutralization reaction, what it is. So neutralization reaction, the reaction between these bases and the acid. Basically, the alkalis react with the acids, whereby in the process salts are formed in the water. So acids plus base, you get salt and water. Now the reaction with the hydrogen carbonates, which are the bicarbonates. Acids will react with the hydrogen carbonates, forming salt water and the electric carbon dioxide. Example of that one is sodium hydrogen carbonate when you react with the HCl, that is the hydrochloric acid, get sodium chloride plus water plus carbon dioxide. So that's all on the reactions of acids with the various materials. I hope it's clear. Thank you guys for listening. Stay tuned to other videos.